If you stood on the summit of Mount Everest today, you'd be 5.5 miles above sea level, shivering in sub-zero temperatures. But look closely at the rocks beneath your boots, and you'll find something impossible: the frozen remains of sea lilies and ancient ocean shells. How did creatures that lived in the dark, warm depths of a tropical sea end up at the roof of the world? It sounds like a glitch in nature, but it's actually the ultimate proof of Earth's restless power. Today, we're following the rocks that remember the water. 200 million years ago, the map of Earth looked nothing like it does today. Between the giant land masses of India and Eurasia sat a massive, warm body of water called the Tethys Ocean.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
For eons, this ocean was a life-producing factory. As billions of microscopic creatures and shelled animals died, their remains settled into a thick, calcium-rich ooze on the seafloor. Over time, the weight of the ocean squeezed this ooze into limestone. But the Tethys Ocean was on a collision course. The Indian tectonic plate was racing northward at about 15 centimeters a year, which, in geology terms, is basically a sprint. When the Indian plate finally slammed into Eurasia, the ocean didn't just disappear. The seafloor was caught in a giant continental vice. Because sedimentary rocks like limestone are relatively soft compared to the hard crust beneath them, they didn't sink. They crumpled. Imagine pushing a rug across a hardwood floor until it bunches up in the middle. That bunching created the Himalayas. The ancient limestone seafloor was folded, twisted, and thrust upward. This process, called orogeny, acted like a giant elevator, lifting the Tethys Ocean's graveyard thousands of feet into the air. This is why the yellow band near Everest's summit is actually marine limestone. These rocks don't just hold fossils, they hold chemical signatures. By analyzing the oxygen isotopes trapped in the limestone, scientists can actually read the temperature of the ocean water from millions of years ago. The rocks remember how salty the water was, how much carbon was in the atmosphere, and even the direction of ancient currents. Every shell found in the desert or on a peak is a data point in a global weather report that's been out of print for 50 million years. This isn't just an Everest story. You can find Whale Valley in the middle of the Egyptian desert, full of whale skeletons with tiny legs. You can find trilobites in the high mountains of Morocco. These wandering stones prove that the Earth is a recycler. The mountain you see today might be the seafloor of tomorrow, and the sand on your local beach might one day be part of a future mountain range. So, the next time you find a shell in a place where it doesn't belong, don't just think of it as a souvenir. Think of it as a witness to a world that was drowned, crushed, and then reborn in the clouds. The Earth doesn't just move mountains, it creates them out of the sea. If you were a geologist, which misplaced fossil would you find most exciting to discover? A whale in the desert or a shark tooth on a mountain? Let us know in the comments. Stay curious.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.